So let's talk about threads in Java. So what basically is a thread? Well, a thread is going to be something that you are going to use to have multiple paths of execution running at the same time. So in your application, a thread is just simply going to be some way to have some other part of that application running at the same time as your main application. In fact, that is what would make an application multi-threaded. It would have multiple threads that are all running at the same time. Now this is different depending on operating systems, and it can be different than a process. A process is very similar to a thread, but a process doesn't share memory. The difference really with a thread is that a thread is going to share memory, and because of this sharing memory, we are going to have some implication that we are going to have to deal with, and we will talk about those a little bit later. But the basic idea of a thread is just some independent path of execution within your Java program, so you can have multiple paths that are running at the same time. So let's talk a little bit about why we would want to use threads. This idea of running multiple execution paths at the same time, it might not seem like it would be very beneficial for us to do that. Why would we want to do something like that? I'm going to give you some specific examples in a bit here, but let's talk about the general case first. So what are you gaining by having multiple threads of execution? It turns out that this is actually a quite difficult problem to solve. A lot of times developers will think that threading their application is going to produce a performance increase when it actually doesn't. It kind of has to be tested, and you really have to have a good reason for using threads, otherwise it might actually hurt the performance of your application. A good rule of thumb for determining when a thread could be beneficial to you or why you should use a thread is basically if you have some kind of resource that your thread is going to be blocked on. So your program is going to be blocked on the execution or using some resource. Think about a disk. For example, if you are writing an application that is going to have to read heavily from a disk, perhaps there is some other thing that can be happening in the background that doesn't use the disk, that can be running on a different thread. And if you have a single threaded application, the entire process is going to have to wait for that I/O operation to read from a disk that might be slow. Whereas if you multi-thread it, it might be able to go ahead and do some other things in the background. And another common scenario is when you might be able to split up some work and do that work in a parallel and then come back together and process it if when order doesn't matter. So if you have some way to divide the problem up into multiple smaller problems and you can execute all of those problems at one time, having multiple threads might help you there. Now it might not always help you because you are having to switch between the processor. Typically a thread is going to use the same process in your CPU, so it's going to have to share that. But those are just some general cases where you might consider using threads.